Not of that. That was wonderful. But what's the point of what we were talking about last class? What were we talking about last class? Why is it important? What was it?
The empirical rule.
What, good. That's a more micro look. Go more macro. I love that, Candace. Thank you. The empirical rule is the last big if thing we talked about. If data is bell-shaped, right? Please, let's do this.
We were talking about how much variation we see from a mean.
Variation from a mean. That was the big idea. Let's start with the big idea, yes? Let's start with the big idea. Variation about or around a mean. What this whole topic was, and we're going to continue it today, the whole topic is how much does data shift around an average? How variable or how non-variable, how consistent or how inconsistent is data? That's the big idea. How consistent, how tightly clustered, how inconsistent, how widely clustered. And we measured that by taking an average, which is a fine number. I got no problem with an average. An average is great. But an average by itself, maybe not so great. Maybe not so great. Today in 244, we were trying to see if the human energy field exists. The whole idea of touch therapy revolves around the human energy field. We were trying to see if we could detect that in 244 today. So I set up an experiment that if students were guessing, they would average a certain number on. I think it was 5. Yeah, it was 5. So if they were guessing at the experiment, they would average 5. But we hypothesized if we could detect the field, they would average higher than 5. So what happened was, we were expecting an average of 5. Guess what their average was? 5.1. 5.1. And I said, is this significant? And they said, hell no. I said, well, how do you know that? And they said, because 5.1 is so...
Average.
I was going to put 2 words in between that. It's so close to average. 0.1 is so close, right? 5.1 and 5. And I said, okay, well, let's take your data and combine it with everybody else's data that I've always collected. I've collected about 2 years worth of data from this experiment. The overall average is 5.6. 5.6 to 5. And I said, is 5.6 higher than 5? And their response was, well, now we're not so sure anymore. Because now it's a half higher, right? It's 5.6 versus 5. It is higher, right? But the question is, what's the spread on that 5.6? It becomes another question of what? Again, another question of, what do you have? Well, trust the data though, Candace. Trust the data. What do you always have to apply to a statistic? We're going to see it again today. 3 words.
Margin of error.
Margin of error. Which we did. We applied the the margin of error to 5.6. And even with the margin of error, it was still above 5. And you should have seen them squirm. It was so adorable. They didn't want to admit that students were detecting this field. And that's when I started going, I'm not proving that we have. All I've proven is that you guys are not guessing. You are above guessing. Guessing was exactly 5. And you guys went from, it was something like 5.3 to 5.9. I said, you guys are averaging above 5. I'm not saying anything about touch therapy, energy fields, alternative treatments, nothing. I'm saying you guys are doing better than guessing. And they were a little bit happier with that. But that's what this is all about, friends. It's all about this plus or minus. Whether it's 1S, whether it's 2 S's, whether it's 3 S's, whatever it is. Whatever it is, it's all about taking, what is this S? Your sample standard deviation. It's that calculation of variability, right? Don't worry about the calculation. I'm not testing you on that anymore. Actually, I've never tested you on that, ever. We just calculated it the one time with Ernie. That was it. What is it, though? What is S? So S. What? Let's throw some numbers in there. Ernie averaged an 81 on his tests. Yes? Averaged 81.
Yes.
He had a standard deviation of, I think it was 1.6. You said average one too many times, Candace. I love it, though. Change one of those averages to the word distance, and I'm a happy dude. Kevin, go ahead. This is Kevin.
It's the average distance away from the average.
You take all, you said, you had 2 averages in there. Average distance from average, you had 3. I didn't say the word distance. I'm being nitpicky. I'm being nitpicky because I want to nitpick on the definition because I don't want to nitpick on the calculation. I want you to use technology to get the number and then know what the hell the number means. That's all I care about. That's what I care about, is knowing what that number means. You'd be amazed at how many students tell me they hate statistics. When I ask them why, they say, oh my God, it was all formulas. It's a terrible statistics class. It shouldn't be all formulas. It should be all interpretation. When you hear that the standard deviation is 1.6, what that means is, on average, if you look at the distance of each data point from the average, that's what the number it averages to. Average distance from the mean of all the data. Do you see how I use the word average twice in that definition? FYI, this is an exam question. You're gonna have to write it out or type it out on your exam. Some of you may have already seen it. If you didn't, you will soon. In the chicken question, what does that standard deviation mean? It's about eggs. Just to give you a heads up, it's about eggs. But it's about average distance from the mean. Okay? That's what it means. Katie, go ahead.
Oh, no.
No.
Got it.
Awesome. That's what I care about. I care about the interpretation. If data is widely varied, what should you have? Large or small S value? Vote for large. Anna says vote for large. I think that's perfectly believable, because varied data means the distances from the average are getting larger. When it's clustered, it's going to get smaller, just like Bert and Ernie. Just like Bert and Ernie. Bert and Ernie were simplistic cases. We'll see less simplistic cases today, I hope. That's my goal anyway, is to see less simplistic cases. Fair so far? So it's a measure of variability. It's a non-intuitive one. I think I've mentioned that. You guys learned about averages when you were teeny tiny, probably like in 3rd and 4th grade. As soon as they learn how to add and divide, it's like, let's teach them averaging. I'm like, well, okay, maybe. Let's teach them algebra in 5th grade. It's like, why? What's the rush? What's the rush? I don't know. But the rush is you know how to do you know how to calculate an average. Standard deviation. How many of you needed this class for the first time you ever experienced the standard deviation? Anybody? This was your first experience with that? Yeah, that would not be. This was the first class you ever experienced an average and the calculation of an average. Yeah, exactly. Oh, we got one. Hell yeah, it's fantastic. Don't usually even get one. Okay. So what I want to do first is I want to focus on one more not computation example. I want to make one more dealing with data example. Speaking of data, who needs the data sheet still? I've got some extra copies of the data sheet here. Go ahead and hand those back. I'm going to keep one. Go ahead and hand the rest of them around. I've got it hyperlinked on the schedule page as well if you need it.